In this module, we're going to look at space frames. Space frames are a structural system in order to create a rigid surface, and that could be a floor system or a roof system or a wall. In the case of the module that we're going to do, we're going to create a curvilinear roof system and then apply this space frame in order to make it rigid. We're then going to keep it elevated and supported by these adaptive columns that we're going to create. And the magic of this whole system is that once we've created all of these elements in the structure, we can go back and modify our shape to change it to make it more aesthetically pleasing or interesting or whatever we might decide to do aesthetically. And our components will adaptively conform to the new surface that we create. We're also going to then finish up the project by adding some context to it. But the focus of our lecture is to take a few minutes and look at what the idea of space frames is as we apply it to our project. So space frames from Wikipedia could be considered a space structure, a 3D truss. Truss is an important word here. It's rigid. It's not intended to be flexible, lightweight, and constructed of these interlocking struts. And this idea of interlocking is really important in order to generate these kind of complex shapes. Because and many times, and most times when they're curved shapes like this, none of the components are identical to each other. So this is an example that's really not unlike the project we're doing. The difference here is that a fabric membrane has been applied to it, just like could be applied to ours. We have the same concepts of adaptive columns. And if you click through on this, it'll take you to the vendor site, which has all kinds of projects that they feature with space frames on it. Important to understand about space frames, they must be triangulated or braced. So at the connection point in Truss, they're considered what's called pinned or flexible connections. So if you had a four-sided shape, you applied load to it, and these pins were flexible, you could easily see how the shape would deform. And so that's why triangulation is important. If we applied the load to the triangle, it's easy to understand that this would not be able to deform. It's the simplest piece of geometry we can create that takes up three-dimensional space, so to speak. And so we should be able to recognize that when we're creating our trusses. So here's a truss system with that kind of triangulation highlighted within it. And it becomes a little complicated to see, and the warning here is that as we modify our trusses, maybe making changes or aesthetic improvements to them, we must always remember to make sure that they're triangulated, that they have that kind of structural integrity to them. This puts it a little bit in the context of history. This is a space frame system supporting a flat roof in an airport, probably in the 70s. So space frames aren't new. We still have the idea of adaptive columns. Adaptive columns like this with these fingers coming out are important in order to bear the load. Any single node on a truss is not able to support the full load of the frame system, so we have to catch a few nodes in order to support it. Imagine holding something really fragile in your hands. You try to cup your hand in order to support it, to bear to keep the weight spread out, instead of pushing through it with your fingers, so to speak. And so the adaptive columns are really trying to do the same thing. So I've said that they're a historic element, or they have a history to them, and they might have an appearance of being dated in images like that. But here we have the SoFi Stadium, a recently considered finished project that's really based on this concept of space frames, making a really elegant and beautiful structure. And if I was to go all the way down here, eventually we would see an image of those space frames. And then now in this case, not covered with fabric, but covered with metal panel systems. And I have a few more images of this in the slideshow. This is also, once again, hyperlinked, so you can visit this specific site. Another, I think, beautiful example of a space frame. This is the Javits Center in New York City. This is the atrium space, or the center entry space of a large convention hall. And the space frame really kind of lightens up the structural elements. Your first look at it, you could say there's a lot of structure going on here. But another way of looking at it is that because the members are very thin, it's almost like a mesh system instead of a heavy structural component. Really, the only way to, I guess, understand that would be to model it with heavy structural components, heavy steel. An example of how heavy those steel components could be is if you take a look on the right here at this column system that's concentrating all the load from the truss systems down to grade. You can see how heavy those elements are. And so if the whole structure was constructed of these heavy elements, I think the appearance and effect of it would be remarkably different. So this is just another, I think, great example of a space frame system. So that space frame's exposed, but here we have a like a subway shelter or a mass transit system with a curvilinear roof system built of a space frame, but in this case the intention of the space frame is to not be exposed. You can see how it looks like there's insulation and wiring and other things going on in here now. This will eventually be covered over with another probably sheet metal ceiling system. And once again, we have that idea of adaptive columns coming up and touching the roof system at multiple points in order to spread out the load of each individual member of that truss system, or should I say it, to divide the load off of any single individual member of the truss system and carry that load down to grade. This is once again another image of that SoFi Stadium. I just think this really kind of is a good image to capture the idea of the space frame. You can see another space frame over here. It's panelized in this case, and you can see how lightweight it is being hoisted up by a crane. In this case, instead of this could have been covered with fabric, but in this case it's covered with these weight painted aluminum frames. And here's just another view of that stadium under construction. And once again, you can see a really strong representation of, I guess, the basis of this structure is these truss-like elements. And a lot of this is really facilitated in our computer modeling that we can do. I wanted to keep the idea of your thinking while you're working on this project lively about what trusses can look like and how they can be a strong visual component at the same time. So here we have what I think are really attractive columns supporting the loads of the building. And if you look in, you can see this kind of repeating adaptive columns here, but you can also see how that's carried in to what looks like an expo hall here. Another thing to call your attention to is the fact that this truss isn't all one thickness up here. So in the center, where there's the most amount of load that wants to bend this roof system down, the truss system is the thickest. And where there's less load to bend it, it thins down. So there are ways to create these truss systems that can be even more beautiful or visually interesting and also structurally relevant. So that's just a kind of an introduction to get you stimulated on looking at truss systems in our simple project, realizing that they could be carried out to much more sophisticated projects later on. So, and I guess the kind of closing to this is one of those really sophisticated projects that would not immediately become apparent as a truss system. I looked at this project for years. This is Zaha Hadid, a beautiful building, famous, obviously. You've probably all seen it. And I never thought what the underlying structure of it was until I did a little bit of research on this and saw some construction photographs of it. And I was immediately surprised by the idea that the underlying structural elements of this are trusses. So here we have it under construction. In some places there's some panels going on, but you can see all of this blue framework is in fact the structural truss for it. And you can even see the ideas of adaptive columns down here. In the very corner here, you can see these three arches or three legs reaching out from a very short column. And then these elements within the truss actually being beefed up in order to take all of the load coming down from these being collected from all the thin members down to this one collection point. And you can see that kind of represented here in these larger members collecting all of the forces from all these very lightweight mesh members coming together, kind of concentrating in this one area. But it's a really good example of this kind of ability to create these three-dimensional shapes with these space frame trusses. And it's important to note that the way this shape is generated is none of these elements, no one particular element is the same length. These are all generated by a computer to a specific length, and when they're all assembled together, you create this beautiful curvilinear shape. And you can do wonderful things with this idea, manipulating the curvilinear shape. So here we have an interior view, and you can see how we're collecting all of that force down into these supporting points with inside of the building. And a good compare and contrast for idea of structural elements, if we were talking about ideas of transparency, this isn't covered with glass, but this is a great place to kind of like point out this idea of the lightweightness nature of space frames. Here we have a walkway going across on the interior space here, and you'll notice the thickness of the steel, the massive element, the ability to not have transparency to it. And then we look up at the major structural roof system, and it has this really high level of transparency to it, afforded by the many units working together in a space frame structure. This is a great view from the top of that. It shows you the curvilinear shape being panelized over here, and gives you a close-up of what each part of the space frame looks like. So these are all screwed into these connector points, these like what are called pin connections. And none of these three elements are the same throughout the whole shape. They're all changing in order to warp the shape of the space frame as it's assembled. And that kind of completes that part of the project. If we're in class, this would be the time where we'll start looking at our assessment for this module.